Alright, this week we're going to cover two operons. So we'll start off with Trp operon. So Trp is for tryptophan, and the regulatory genes are the promoter, repressor, operator, and leader sequence. So the leader sequence is very much needed for the attenuation, which is a special feature in Trp operon not available in lag operon. And there are 5 structural genes again named Trp D, C, B, and A. So Trp encodes the enzyme adrenalate synthase 1. Oh, I'm missing C there. So Trp encodes for the enzyme adrenalate synthase 2. Trp encodes for the enzyme N5-phosphoribosyl adrenalate isomerase and indole-free glycerol phosphate synthase. Trp encodes the enzyme tryptophan synthase B subunit, and Trp encodes the enzyme tryptophan synthase A subunit. So Trp operon is negatively regulated, but it is a repressible operon, unlike lag, which is inducible. So we know that it encodes the 5 genes, and the 5 genes basically, for each and every one of them, single mRNA are produced, and in total they make 3 enzymes, okay, from combination of the 5 polypeptides. So the end product, okay, will produce tryptophan, which is a form of amino acid. And this is where Trp operon is different from lag and ara, because arabinose and lactose are sugar. So Trp operon is turned off when there's enough Trp, or Trp has been accumulated. So in this case, Trp acts as an effector molecule. So this is the linearized version. So we have the 5 structural genes over here spanning around 6.8 kbp. So we have a promoter here, the operator, okay, the leader region with the attenuator sequence, okay, for termination, transcription pause site and transcription termination site. So we will have a look in a while what is the function of attenuator and why attenuation is only occurring in Trp operon. Now, Trp operon, in the absence of tryptophan, the 5 genes, okay, will be transcribed to produce Trp, because there's no Trp, so tryptophan needs to be produced. So we know that, okay, each and every one of them codes for 5 enzymes, but in total they will make only 3 enzymes, and these 3 enzymes, okay, will basically, okay, synthesize tryptophan so that it could be used by the bacteria for its survival. Now, the regulation of Trp operon, okay, is that, okay, a lot of bacteria, okay, one of them, for example, E. coli, could synthesize its own tryptophan, and it will cease to produce tryptophan when tryptophan is present in the environment. So that means that it doesn't need to make its own Trp, okay, to survive. So that means that, okay, the 5 genes expression, okay, the Trp to Trp is of course sensitive to levels of Trp available, and the scenario is as such. So we have a Trp-R, okay, which is a repressor protein that binds to the operator sequence, and this would prevent transcription, classic form of gene expression. So Trp-R can only bind DNA if it is simultaneously binding a molecule of tryptophan. So a tryptophan, okay, if it's available, it will bind to the Trp-R, so that means that, okay, it will drop off from the operator site, and hence when Trp is present, Trp operon is turned off by the repression of Trp-R. So in high Trp level, repressor protein, which is the Trp-R, binds to the operator, hence causing no expression of the Trp synthesizing enzyme, and no tryptophan will be produced. In the absence of tryptophan, Trp-R cannot bind to O, because of course obviously tryptophan is not there to bind, okay, to the Trp-R. So continue expression of Trp operon to produce tryptophan as needed, not too much, not too low. So these are the components, okay, the promoter, operator, the leader sequence, plus the attenuator, okay, which is over here. We have the repressor gene, which is somewhere upstream, and we have the structural genes, okay, toward the 3' side. So we know that, okay, in the repressor protein, okay, Trp-R produces a repressor protein, so there is a tryptophan binding site, and tryptophan is a co-repressor. So when tryptophan is absent, there is no tryptophan, and for the case that the enzyme basically, the bacteria needs, okay, tryptophan. So what happens is that, okay, the repressor protein, okay, will not be able to bind to the operator, because repressor alone cannot bind to the operator. It has to basically have the help of the tryptophan as a co-repressor. So without the repressor there, what happens is that, okay, nothing that could prevent RNA polymerase from binding to this site, hence transcription could occur whereby all these 5 structural genes could be produced, and polycystic mRNA will be produced to produce tryptophan for the bacteria to use it. Now, when tryptophan is present, so that means that in the case after it is absent, so it has been made, it has been accumulated, so tryptophan is present. So what happens is that the repressor protein over here, and because there are tryptophan, tryptophan will bind to the repressor protein at the binding site, tryptophan binding site. So this binding, repressor bind to the tryptophan, causing allosteric transition, which means that the repressor tryptophan complex will bind to the operator. So when it binds, what happens is that classic case of it will block the RNA polymerase from binding to the operator site for the transcription. Hence, transcription is blocked. So it's the opposite to the lag operon. Now, in terms of the mechanisms of the regulation, there are 2. So the first one is repressor. The second one is the attenuation, which is a special feature for the Trp Operon. So in the first mechanism, whereby a repressor or operator is there is an interaction between repressor and operator. So Trp acts as the effector molecule, and Trp binds to the Trp-R because it is a co-repressor. So when it binds, gene will not be synthesized, hence tryptophan will not be produced. So in the case of the second mechanism, whereby attenuation control regulatory leader region, so it will determine if initiated transcript include other structural genes or not. So it will determine whether there is sufficient Trp or more Trp needs to be made or needs to be stopped. Now, let's have a look at the Trp attenuation, and probably listen to this carefully or refer to some other references to help you to understand this better. A lot of students usually got confused with Trp attenuation. So this is basic attenuation of tryptophan is basically an addition to negative regulation of the operon itself. So there are 2 scenarios in the absence of tryptophan or in the presence of low tryptophan. So there is only 2 scenarios, absence or presence of low tryptophan. So under severe tryptophan starvation, which means that there are no Trp for a certain period of time, so all transcripts of the 5 structural genes basically will be made in long transcripts. So gene activity is basically said to be at maximum. But under less severe situation, which means that probably there are Trp, but the level is actually very low. So there is combination of long and short transcript being made, and expression is basically at less than maximum, because if you have long transcript, then that would be at the max. So the greater the amount of tryptophan, the greater the number of short transcripts. Now, whether it is short or long transcript, doesn't mean that long is good, short is not good. So it doesn't mean so. So the attenuation basically controls the termination of transcription, producing short transcripts. Now, this is basically how the attenuation is being grown. So remember the leader region, just before the start of the 5 structural genes. So the attenuator is basically situated there, just upstream of the Trp E. So it basically has an attenuator sequence, as you can see over here. So it has a start codon AUG. So within the attenuator sequence, there are 2 sets of inverted repeats. So there are 4 regions, or 4 repeats. So we have region 1, 2, 3, and 4, but only 2 sets of inverted repeat. 1 and 2, which should form a loop, or 3 and 4. So these inverted repeats will form hairpin in moderate presence of tryptophan. So there are possibility of 3 hairpins. So more or less this kind of like an algebra. So 1 and 2 hairpin, 2 and 3, and 3 and 4, all possible scenario. So within repeats 1 to 2, there are the sequence UGG, UGG, 2 repeats. So when repeats 1 and 2 form a loop, or a hairpin, repeat 3 will form hairpin with a repeat 4, and this will immediately stop the transcription. Now, when hairpin between repeats 3 and 4 terminates transcription due to the presence of this string of U's, Okay, so what happens is that it is a classical row-independent terminator sequence. So remember back again the termination of transcription, okay, way back in week 1. So this is one of the example, but row-independent termination. Now, the attenuation control occurs at the mRNA level, of course, during the transcription of the structural genes. So it can reduce transcription of Trp Operon around 8 to 10-fold. And the position of the ribosome for the latest transcript basically determines if the transcription is going to be terminated or not. For example, if starved for tryptophan, so that means that it will lack the tRNA, the one needed, okay, for the production of tryptophan. So if there is no tRNA, ribosome will stall at the trip codon over here, okay, at the repeat 1. So with ribosome on the region 1, okay, loop 1 and 2 basically could not form, okay, because ribosome stalls there. So loop 2 and 3 will form, and this is basically, okay, a form of anti-termination. Hence, region 3 and region 4 cannot pair up, and we know that when region 3 and region 4 forms, okay, a hairpin, which means that it signals for termination. So RNA polymerase can continue, and transcription of the gene, structural genes, okay, could occur to produce tryptophan. So just remember this 3 and what it means. So if 1 and 2, repeats 1 and 2, okay, form a loop, it will cause a pause. Pause meaning that this, okay, could not basically more or less form together. Sorry, this 2 and 3 again will form, okay, together to form the anti-termination, which means that through 3 and 4, okay, could not be formed termination. So transcription will continue. But okay, if it doesn't stall there, okay, it will continue. So it will come across the stop codon. So what happens is that, okay, these two, okay, will basically just continue, and this, okay, will form a loop. Okay, so if this forms a loop, okay, still it could continue transcription. But okay, you also have to bear in mind, okay, sometimes, okay, when these two occurs together, this two, okay, will also form a hairpin, which signals for termination, which means that transcription will stop. Okay, let's take a look, okay, at the condition, the two conditions just now. So if it is starved for tryptophan, which means that there are no tryptophan at all, so transcription will continue, okay, because ribosome basically stalls, okay, at the repeat 1. So repeat 2 and 3, okay, will form hairpin, okay, which means that, okay, this is an anti-termination. Transcription could continue, okay, so it will prevent formation of 3 to 4, which is termination. But if there are tryptophan, okay, whether low level or high level, usually it's quite low level, okay, what happens, okay, is that, okay, the ribosome, okay, will pass through repeat 1, okay, going through repeat 2, but okay, it basically could not pass through repeat 2 because, okay, repeat 3 and repeat 4 basically will form a loop, okay, with one another. So 2 and 3 actually doesn't form a loop, okay, it's just 3 and 4. So termination signal for RNA polymerase, which stops the transcription. Now, this attenuation occurs in the presence of moderate amount of trypt, okay, so usually moderate to low level. Now, ultimately, of course, this is the secondary structure which will form, okay, if trp is present, okay. So if 1 and 2, okay, you will get 3 and 4. This will stop the transcription. So stall ribosome, which means that, okay, if it's stall here, okay, 2 and 3 will form, and when there are 2 and 3, it basically signals for anti-termination. Transcription could occur, okay. So this usually form at low concentration of tryptophan to enable tryptophan to be produced. Now, transcription of the Trp Operon, okay, usually has begun at this case, okay. So what happens is that RNA polymerase has transcribed from the +1, okay, into the trp leader sequence at the attenuator site. So the line and the boxes, basically what you see here, okay, represent the newly synthesized mRNA from the Trp Operon itself. So the ribosome, okay, has bound to the first AUG, to the first start codon of the leader sequence, and begin translation. So RNA polymerase could then continue transcription into the region number 2. Now, at moderately low level of tryptophan, attenuation will occur. So yeah, this is basically uncontrollable. Sorry about that. So RNA polymerase will continue transcription of the leader sequence, and translation proceeds to the 2 trip codon, as you can see over here. The 2 repeats. Since there is some moderate amount of trip in the cell, so trip tRNA is produced and can be used by the ribosome. So since trip is present, translation will continue through the 2 trip codons on the stop codon, and of course continued into the region number 3 or repeat number 3. So now what happens is that translation will terminate once the ribosome reach the stop codon which is situated after the region 4. So RNA polymerase has continued transcription into region 4. Now, once the ribosome dissociates, region 1 and 2 can and will form a hairpin structure. So when it forms a hairpin structure, immediately region 3 and 4 will also form a similar structure, and hence it signals for termination, resulting in transcription termination. So basically, I'm just explaining this again in an animation. So this is actually how it occurs. So the animation is basically quite fast, but if you were to look at your notes, that is basically how it occurs, step by step. So at very low levels of trip, it will prevent attenuation to allow trip, to be transcribed, which we know. So when translation begins, sometimes it will stall, as it reaches the true trip codon in the leader sequence, and this will enable RNA polymerase to continue to transcribe the leader sequence. So if region 2 and 3 forms, we know that that is anti-termination, so RNA polymerase could continue to transcribe. So in any case, the desired is basically for the ribosome not to be basically have any problems, or basically if it is stalled at region 1, it should be fine, because region 2 and region 3 will form, which basically signals for anti-termination, which will allow transcription to occur. So as you can see, this diagram basically explains generally attenuation of the Trp operon of the mRNA. So we only have 4 domains, or the 4 regions. So low trip level will happen, slow translation of domain 1 peptide. So domain 2 and 3 will pair to form hairpin. So what happens is that normal full gene transcription to produce tryptophan. But at high level of tryptophan, fast translation will occur of domain 1, which will continue into domain 2, and domain 2 usually will be blocked by the ribosome, because there is also a stop codon over there. So when this happens, domain 3 and 4 will pair to form a hairpin loop. So we know that would signal for termination, and this basically is a form of attenuation. So attenuation of transcription will occur, and only 10% of normal mRNA will be made, because up until at that site, then transcription will stop. Alright, so if you have any queries on tryptophan, so we will discuss it further on Monday, and have your questions ready and be ready to be asked as well by me.